Hey, sorry about that.
That's okay. It looks like we are here and it looks like we are live, so we can give this a quick run through and
Okay.
see how things go. So I'll go ahead and
Okay.
start our slideshow from the beginning. This is our Understanding Object-Oriented Programming presentation for CIT260 group presentation project. My name is Michael Crump.
My name's Alicia Mitchell.
And here we go. The 7 steps of developing a function. So, one of the most important aspects of Java that we have learned so far is how to create a function, also known as a Java method. Functions are collections of statements.
Oh, sorry. Am I supposed to go?
No, so I'll read our introductory thing, and then once I get to we created our function as follows, then you can pick up step 1.
Okay, perfect. Yeah.
So we've been taught to approach function creation with a thorough 7-step process that results in fewer errors, easier coding, and a better understanding of our overall program. One of the first exercises we had where we used this 7-step process in its entirety was a creation of our main menu view. We created the function as follows.
So our first step, we had to clearly define the problem. So we needed to know exactly what our function was supposed to do and what our input and output values would be. And if there were any validation rules, we needed to define those. Our function needed to result in a menu view to the end user that displayed the options for navigating into and out of the program. So each option on our menu would have a corresponding letter that the user could input for their selection. Depending on their input, the corresponding output would be displayed. So if the user tried to enter a selection that was not listed though, we knew that the program would return an error message prompting the user to go ahead and try again.
Yeah, and step 2, we had to create a test matrix. The test matrix is a table you create to show valid, invalid, and boundary inputs for all variables in your function. For our main menu view, we knew that the variables would be each of the 7 options we wanted to display for starting a new game, starting an existing game, getting help on playing the game, saving the game, showing the game map, viewing information about us, and exiting the program. So we placed these 7 variables on the left side of our test matrix table. And in the next column, we then entered the valid inputs for each of those variables, which was the corresponding letter that was displayed to the user for each selection. In the next column, we entered random invalid entries for each selection. And then below the valid and invalid entries, we listed what the output values should be for each. We knew that the valid entries should return the correct corresponding selection, and that invalid entries should all return a generic error message prompting the user to try again. And because there was only one valid input for each selection, we did not have to worry about boundaries for this function.
So then our third step, we needed to create an outline of the solution as a algorithm. So an algorithm is a process or set of rules to be followed in calculations or other problem-solving operations. So we developed that's what a test run's for. We develop algorithms for each of our functions to organize our thoughts and outline the problem in easy to follow steps. We use a form of pseudocode to write the algorithms, a language that is close to actual Java language, but without all of the nuisance and details of the actual code. So for the main menu, our algorithm used a generic function template for getting user input. It ended up prompting the user input and continued to do so while the valid value had not been entered. When a valid value was entered, The function received that input, trimmed any front or trailing blanks off the value, and returned desired selection.
Step 4, we then tested the algorithm. Testing the algorithm involved us pretending we were the computer and listing out what variables would be allocated to memory for each of our test matrix cases and what the proper outputs would be for each input. This step helps us to identify any problems before we get into the actual coding, and it could kind of be seen as writing an outline for a research paper. We created a new table with all of the valid menu options as variables in memory locations. Then we walked through each possible input and listed what the output should be. And seeing that our test results matched our expected test matrix results, we knew that our function and design were both on the right track.
And for our fifth step, we then translated that algorithm into code. Now this is where the fun began. So we started translating our algorithm into code, it involved taking each step and converting it into a readable Java code. So this began by us creating the function signature, which defined the inputs and outputs of the function. We prompted for user input, and while it was valid, we captured the input as a string. And then we used a switch statement to compare their input against the 7 menu options that we wanted to display. If the user input didn't match any of the listed options, or as we would call it, invalid option, we would have a default println line that would alert the user to go ahead and try again. So we created methods for each of the switch cases that would call various menus depending on the user selection. So using NetBeans to develop and write this code really did help us define or identify any errors that came up while we were writing the code, as well as running the program and actually seeing what the users would actually see.
Step 6, we run test cases to verify that the code is working as specified. While we didn't use testing specifically for our main menu, this step should be utilized to verify that the function is working as specified in the test matrix. We did implement this step in lesson 5, where we wrote code and implemented test cases for one of our complex equations end user stories. The test cases are ways to verify each of the test matrix input variables within NetBeans itself. NetBeans has a preloaded option called JUnit, which we were able to use to test the various options, confirm our expected results. If the test matrix and the test case results were both equivalent, then the test was considered successful. If they were not equivalent, then the test failed, and we knew we had to go back to either our algorithm or code to correct our logic.
And then for our last step, step 7, we deployed the changes to the repository. So after we verified that all of our code and functions were operating as expected and that there was no errors remaining in our program, we went ahead and pushed our code to both our local and our shared repositories. We first had to save our changes and commit our code with the revision date and the pertinent notes for the code that we just had written. And then we pushed our code to the shared repository, which allowed us to work on the same code simultaneously, which was really great. And we could either pull or push our changes back to the repository for the other team member to see and use. It was a great way to share the files, and it allowed us to see the revision and the histories. And so that way we could revert to prior versions if necessary, and then accept corrections and improvements to our code, which was awesome.
Yeah, awesome. That's the 7 steps of developing a function.
So
got some example code here. The code on the left, you can see, was written as part of the items Java view class that I had just created this week as part of the individual assignment. Its function is to retrieve the user input, check to see if it's valid, and then return either the appropriate selection or an error message. So running through the code here at the top, the private keyword means that this input could only be used by objects of the same class. The Boolean valid equals false was a statement indicating if the name had been retrieved or not. The while not valid statement tells the program to continue requesting input while a valid option has not been retrieved. And these next 2 lines here, the get input, we're going to get the selection from the keyboard and then trim off any leading or tailing blanks from their input. The if get input length was less than 1, check to see if it was a valid entry or not. If they tried to input something that was less than 1 character, we knew that would be invalid. And then at the bottom, the return get input, the program was going to return the user's selection.
So my example code, I chose to use one that was part of the start program view.java class. Its function was to retrieve the user input of the username, the start program view, and the display banner with the user's name, which was inputted by the user. So first we see here the public keyword, which means this input can be seen and be used by objects of all classes. The second thing that I wanted to point out was just a simple string keyword sorry, my brain's gone. The string keyword means that if the name has the name can be retrieved. The this keyword explicitly specifies which item you are trying to reference, which becomes really handy when you're coding. The next thing that I wanted to show here was referencing an item. So we needed to reference the main menu, and so we had to make a new instance in a class in Java, and we had to use the new keyword to create that instance, and then we called it in its constructor function. And then we went ahead and we used that instant variable that we just created, and we did reference it. And as you can see here, it's the lowercase main and uppercase menu thing that we created right here to call the main menu.
Okay. Our control function unit tests. Here's an example. So creating JUnit test cases in NetBeans helps you run through your test matrix possibilities with actual code. And the below unit test was written for, it was a couple weeks ago, for a water puzzle scene where users will have to determine how long it will take to fill a large tub with water. So we've got input values for the test case with the volume and the GPM, gallons per minute. We're going to be filling the tub. Those were going to be the input values for the test case. We knew the expected results. The expected output value was going to be 18.18. They were going to have to fill the tub 3 times. The tub was 40 gallons, and it was filling at 2.2 gallons per minute. So we knew the expected result should be 18.18. The puzzle scene water instance statement was going to create an instance of the puzzle scene water class. The double result instance statement calls the function to run the test. And the last line will compare the expected return value with the actual value returned.
Awesome. And my control function unit test was pretty similar to Mike's. Mine is for the teaspoon puzzle square that we created a few weeks ago, and so the first thing that I wanted to point out, because it is so similar, is that I ended up having 3 different inputs for this test case, and so that then next was the expected output value. That was the result of 786. And then we had to create an instance of the puzzle scene teaspoon class, which was for that puzzle. And as you can see here, I used that new keyword again right there. And then the next thing was calling the instance and the function as well to create the result, and then we the next step was to output it. Now, then the next thing that we wanted to talk about was pass by value or versus reference. And this one can kind of seem pretty close to each other. At least I thought I felt that way when I first looked at it. But when you look closely, I've already talked about referencing quite a bit. So I'll just kind of tell you the basic differences. So passing by value means the actual value of the types that are being copied to the corresponding parameters variable in the function are going directly. I'm not communicating well.
I'm not picking up your cues at all. I don't know.
Okay.
For a clicker, that's what you need.
Yeah. Gee whiz. Do I need to? I might need to go and feed my son, and then I could hop back on. Just give me one more minute. And then, sorry.
No, if you gotta go, that's cool. We can. This is just a test run. I think we're over
time.
Over 15 minutes on this. Not that that's a bad thing, but
okay.
Yeah, let me check do what you got to do. Send me an email when you're ready again, and we'll pick it up again. Okay.
Okay, sounds good. That'll be good.
All right. Thanks.
Thanks.